Welcome back to day 4. You hear this word constantly. The model. Train the model. Run the model. This model is huge. That model is better. It's maybe the most used word in all of AI. But almost nobody stops to explain what a model actually is. Today we fix that. By the end of these few minutes, you'll have a crisp, simple mental picture of exactly what a model is. And to make it concrete, we'll train a real one. Save it to a file you can hold on to, and then load that file back up and reuse it. Let's demystify the model. Here's the one-sentence version. So simple it almost feels like cheating. A model is a learned recipe that turns an input into an output. That's it. You give it something, it gives you back an answer. A photo goes in, the label cat comes out. An email goes in, spam or not spam comes out. The details of a house go in, a price estimate comes out. The model is just the thing in the middle that does that conversion. And crucially, that recipe wasn't written by a person. It was learned from data, exactly like we saw yesterday. Picture it like a machine with a slot on each side. You drop an input in the left, and an answer pops out the right. Same machine, totally different jobs depending on what it learned. Show this one a photo, it tells you what's in it. Show it an email, it tells you if it's spam. Feed it the details of a house, it predicts the price. The model itself doesn't change between predictions. It's a fixed, trained thing. You just keep feeding it new inputs, and it keeps handing you answers. Hold that image in your head, the input-output machine. If you've ever written a tiny bit of code, you know about functions. A function takes an input and returns an output too. So how is a model different? With a normal function, you, the human, write every rule by hand. It does exactly what you typed, the same way every time. A model also takes input and returns output, but nobody wrote its rules. They were learned, automatically, by training on examples. That's the magic difference. So where does a model come from? It's the leftover, the result, of training. Remember yesterday, the guess check adjust loop running thousands of times? That whole process is training. And when it finishes, what you're left with, all those tuned internal settings frozen in place, that is the model. Here's the part people find surprising. Because it's just a set of learned numbers, a model can be saved to a file, just like a Word document or a photo. You can store it, copy it, share it, and load it back up later without ever retraining. Let me prove it to you. We're going to do 3 things, for real. First, train a model to recognize handwritten digits, like yesterday. Second, save that trained model to a file on disk. And third, and this is the key part, we'll load that file back, as if we were a completely different program running days later, and use it to make predictions, with no retraining at all. If a model really is just a saved recipe, this should work instantly. Let's find out. Here's the first half. We train the model on our digit images, just one line, model.fit, the learning step. Then comes the new idea, this last line. joblib.dump takes our freshly trained model and writes it out to a file called digit_model.joblib. Read that line again. We are saving the model to disk. After this runs, the trained intelligence isn't just floating in memory. It's sitting in a file on your computer that you can keep. Let's run it. And there it is. It trained, and then it's saved. Look at that second line. Our entire trained digit recognizer is now a single file, and it's only about 6 kilobytes, smaller than most photos. That little file contains everything the model learned about reading handwritten numbers. We could email it, put it on a server, ship it inside an app. The training is done, captured, and frozen into that file. Now for the real test. Now pretend this is a brand new program, running days later, on a different computer even. Notice what's missing here. There is no training, not a single fit, no examples, no learning loop. We just called joblib.load to read that file back into a model, and then we immediately start asking it for predictions. If a model is truly just a saved recipe, this should just work instantly. Let's run it and see. Boom. It loaded the model from that little file and immediately started reading digits correctly with 0 retraining. Image 7, it says 7. Image 42, it says 1, correct. 508, correct. The model we trained earlier is now doing useful work in a fresh program, just by loading a file. That, right there, is the whole point of a model. The hard work of learning happens once. After that, it's a reusable tool. This is one of the most important ideas in all of practical AI, so let it land. Train once. Predict a million times. Training can be slow and expensive. Sometimes it takes huge computers days or weeks. But the model that comes out the other end is cheap and fast to use, over and over. It's a bit like writing a cookbook. Developing the perfect recipe takes real effort, one time. But once it's written down, anyone can follow it, again and again, in minutes. So let's pull it all together. A model is a learned recipe that turns an input into an output. It's the result you get after training a system on data. It's a real, concrete thing, often just a file, that you can save, share, and load back whenever you need it. And the whole reason that's so powerful is train once, reuse forever. Every time you hear someone mention a model from now on, that's the picture in your head, an input-output machine, learned from data, saved, and ready to go. And that's a model, no longer a mystery word, just a learned recipe you can train, save, and reuse. We keep coming back to one ingredient that makes all of this possible, the data. So tomorrow, we're going to give data the full spotlight it deserves and see why it's truly the fuel that powers every model and why great data beats clever tricks almost every time. Thanks for building with me today. See you tomorrow on AI in 5.